Hi, it's Kevin Farlee. I'm a program manager in the SQL Server storage engine, and I'm going to be talking to you today about active secondaries, enabling backup on secondary. So this is all within the context of an always-on availability group, and what it enables you to do is offload your backup to any replica within the availability group. Now, always-on availability groups are similar to database mirroring environments, but there's some significant differences. With database mirroring backups, they're only allowed on the primary. If you try to do a backup on the secondary, it would fail. With always-on availability groups, the backups can be done on any server. The secondary cannot be leveraged for backups in database mirroring, and that means that your backup workload is always going to be hitting your production server. So it's going to be taking away CPU and I/O resources from your production server. With enabling backups on secondary, in contrast, your backups are allowed on any replica. Primary and secondary can both be leveraged for your backups. Backup workload doesn't impact your production server then. It's a really highly requested feature. From the time that we first introduced database mirroring, one of the top customer asks was to be able to use the secondary server as backup server, to do the backups on the secondary server without taking up production resources. And that's what we're delivering here today. So again, the capabilities that you get, you can do the backups on any replica of the database. The replica can be synchronous or async. Either way, it doesn't matter. Backups on the primary replica still work. We're not taking anything back, so that's still anything you've got set up that expects to do the backups on the primary work just fine. Log backups on all the replicas form a single log chain, and that's critical when you go to planning your restore strategies. But there's another feature in SQL Server 2012 that makes that much easier to do, and that's the Recovery Advisor. And we'll be talking about that much more and demonstrating it later on. So just to illustrate pictorially the point about the log backups all forming a single chain, if you have log backups that were done back and forth between two replicas, so you have replica 1 and 2, and you did one backup on replica 1, the second on 2, 3, and 4, you'll notice that the log sequence numbers don't overlap between them. And the log sequence numbers represent sets of transactions within the transaction log. So in order to replay all of those in a sequence, you have to have all of those backup files in order to do them. And that's why we recommend, when you are setting this up, that all your backups be kept in one place. One tip and trick about this is that differential backups are not supported on secondary. Only copy-only full backups are supported on the secondary. For primary, differential backups work, normal full backups work. The only distinction between copy-only full and normal fulls is that the copy-only full does not support differential backups. Again, it's advisable for your backups to be stored centrally, whether that's done by doing your backup directly to common file share, or whether that's done by copying the backups to a file share after the fact. Either one works. So now I'd like to show what this looks like in practice when you do the backups on both primary and secondary. In this demo, we're going to show doing backups from both a primary replica as well as a secondary replica within an always-on availability group. So to introduce you to the configuration here, we have an always-on availability group with 4 replicas, always-on serve 2, 3, 4, and 5, and 1 availability database, which is BOS demo. So we're going to use the BOS demo database. We're going to create a table and insert some data so we have something to back up, otherwise it's not an interesting demo. This tab is connected to the always-on serve 2, which is the primary, as you'll see here. This tab is running on always-on serve 3, which is in the secondary role. In a database mirroring environment, you wouldn't be able to successfully back up from the secondary, but with always-on availability groups, it works just fine. You'll notice that this backup is done with copy only, which is a restriction for doing backups on secondary of database backups on the secondary. Going back to the primary, we'll insert some data so that the contents of the full backup and the log backup are somewhat different. And now we'll demonstrate doing just a normal log backup from the secondary, showing that it works just fine. Moving back to the primary, we'll insert another row of data and demonstrate that you can do log backups, or full backups for that matter, from the primary as well as the secondary. So either way, primary, secondary, works fine. These backups are being saved to a common network share, although as noted, you can also save them to local disks, not a problem. And then we're going to drop the table just so that we'll demonstrate in the restore portion of the demo that it works just fine, so that there's something to restore. And now that we've done the backups, I'd like to show you what it's like to do the restores in this environment using the Recovery Advisor. Now we're going to show how to use the Recovery Advisor to make restoring a database created using backups on various different replicas simple and easy. In fact, it makes restoring any set of backups much easier, particularly when you're going to a specific point in time. So we're going to use the GUI here to bring up the Restore Database wizard. We're going to restore it from a set of backup files. So we're going to add backup media. And instead of going to the default location, we're going to specify the share that we send all the backup files to. And there you see all the backup files that we made, plus some that I made yesterday for something that I'll show you in just a bit. You add those backup files. Now, if you had done your backups each locally to each individual replica, you can then repeat this cycle and add more and more backup files from whatever location they are in. So you don't have to have them located in the central location, but you do need to get to all the backup files from the place that you're doing the restore. So say OK, and you'll see that there's only 3 backup files listed, even though there was many more than that that we tagged as to being used. That seems strange. So let me show you what that's about. That's about this timeline feature, which is one of the coolest features of the Recovery Advisor. So by default, it picks that you want to restore to the most recent possible time, which is usually the most frequent time that someone chooses to do a restore. But with the Recovery Advisor, this is going to show you graphically the entire range of span of time into which you can do a restore. So you can restore the last backup taken or to a specific time, date and time. So all you have to do is either type in the specific date and time that you want to do the restore to, or simply move the slider back and forth, right? So here's yesterday I did a full backup and some log backups back there. So we can restore into any point in time in this entire range simply by moving the slider back and forth. So if we pick a time in the past before the exercise where I just did the full and log backups, you'll see it chooses a different set of backups. It's going to pick the right set of backup files from the suite that you gave it and pick whatever backups it needs to accomplish the restore that you're calling for. If we move this back to the last backup time so we can show the data that we just used in this demo. Because we don't want to clobber the original database and because you can't restore over a database which is currently part of an availability group, we're going to relocate the files, and that's also why I renamed the database. So we're just relocating them to a separate directory so they don't conflict. And since we're not overwriting the original database, we don't need a tail log backup. And now we're ready to go. So what this is going to do is it'll restore the full backup, and then the first transaction log backup, and then the second transaction log backup. And you see this is using the backup header only information set looking into the contents of each backup file to find out what's there. It's not relying on what's in MSDB. So you see which server they were all done on. And now we just click OK to restore, and the backup restored successfully. Just to show, the last thing we did in our demo was to drop my test table. So that should not succeed. And indeed, we see invalid object name because the test table doesn't exist. Now we do use the database that we just restored and do the same query, and we see all 4 rows that we had inserted into the test table. So indeed, the backup was restored as of the time when we did the last log backup, the last backup that we have. Simply and easily, everything's up to date. So now we have shown that we can do backups and restores on the primary and the secondary. The next question that comes up is automated backups. Almost every production system I've seen uses automation to do the backups. There's some kind of scripting solution. Database mirroring, because only the primary would work, it's easy to do your scripting because you can just set up backup jobs on both sides and only the primary would work. So at any backup cycle, only one machine would be taking the backups. With active secondaries, both sides would work, and that's not necessarily what you want. So the solution to that is we've created a declarative policy which allows you to specify where you want the backups to be done. There's 2 levels to this declarative policy. The first one is a preference where you can determine which role you want to use. So do you want your backups to happen on the primary only? For example, if you want to use differential backups, you might choose that. If you want the secondary only, if you never want that workload hitting your primary server no matter what, that would be the choice. Prefer secondary is the default choice, and that's the one we expect most customers to use. And that's where, if there's a secondary available, we'll use that for the backup. But if only the primary is available, we'll choose that. And then the last option is don't care what role you have. I'm going to use a different criteria for choosing which node to do the backup on. And that takes us to the next level of the policy, where we have the ability to set a relative priority for each replica. So for example, if one replica is in a remote location, you wouldn't want to choose that. So you give it a very low priority or 0, which would disable it. Maybe you have a machine that has extra resources for doing the backup and you want it to be chosen, so you give it a high priority. And the way we use that then is we'll filter out any replica that's not up and online. We'll filter out any replicas that don't meet the policy for which role we want. And then we'll select the highest priority replica among the remaining set. The policy is advisory only, it's not enforced. In other words, if you sit down and request a backup specifically, we're not going to prevent that. It's used in maintenance plans and log shipping or in any scripted backup job that you did. The idea is that there would be a preamble in the script which calls a system function, which I'll describe during the next demo, and that tells whether you're currently running on the preferred replica or not. If you're running on the preferred replica, it returns a true and you do the backup. If it returns a false, you just skip the backup and return normally. So let's see what this looks like in action. In this demo, we're going to show the automation features which make backup on secondary feature simple and easy to use in an environment where you have automated backup scripts. And the inputs to these are all properties of the availability group. And here you open up the backup preferences pane. You have a set of 4 policies which determine how we want to treat the primary replica role. You can prefer that backups be done on secondary. You can say secondary only, which means we would never choose the primary to do a backup. You can say primary, which will choose the primary to do the backups, or any replica if you want some factor other than the role to determine which node should do the backups. Once we've determined the set of replicas which are candidates to do the backup, we then sort on the backup priority. And this is in the range of 1 to 100, with highest being the most likely to be chosen. If there's a tie, as there would be between 2 and 5, we then sort on instance name, just as a tiebreaker to make sure you get the same answer every time you ask the question. In this case, since the primary is on serve 2 and we've chosen prefer secondary, we would expect serve 4 to be the one that would return true and be chosen for doing backups. So let's look. This is Windows running on serve 2. This function, backup is preferred replica, is new with always on, and it simply returns a 1 if this is the preferred replica, 0 if it's not, and it's used in automation as we'll show. And indeed, this returns a 0 because this is not the preferred replica. If we run the same on serve 4, which should be the preferred replica, the answer is a 1. So we would prefer to do it there. So how does this work? How would you use that function? Well, this is a sample to a very simplistic backup script. So this says if this is the preferred replica, if the function is preferred replica, does not return a 1, then you just put out a message saying this server is not the preferred replica to back up this database. If it does return a 1, you'll skip that and go ahead and do the backup. So again, if it doesn't return 1, you'll put out a message and just drop through to the exit. If it does return a 1, you go ahead and do the backup. The message, of course, is optional, but it's a nice way to have a marker that the job actually ran and made a decision to not do the backups. So let's see what happens if we run this script on serve 2, which should not do the backup. And we see that the script puts out the message, always on serve 2 is not the preferred replica to back up the database BOS demo. And if we run the same script on serve 4, which we would expect to do the backup, indeed it does the backup. So this is how you can use the automation features built into the always on availability group functions to enable you to cleanly script your backups and run them on any node. So now that you've learned a bit about backup on secondaries, I'd encourage you to go to the Virtual Academy, learn more about the release as a whole, download the bits and play with them, get some experience with it, and participate in the other launch events. There's lots of interesting stuff out there.